The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the question, there is a RLC circuit which is as shown in the figure. The circuit RL circuit which is as shown in the figure. The circuit has a voltage source which is a unit step function which is connected in series with a parallel combination of 1 Henry inductor and 2 ohm resistor. This combination is in turn connected in series with a 2 ohm resistor. The current through the 2 ohm resistor is marked as I of t. It is given that the initial value of the current through the inductor, that is IL of 0 plus, is equal to 1 ampere. We need to find the value of I of t for t greater than or equal to 0. So from the given data, we see that we need to analyze the circuit for t greater than or equal to 0. As the circuit contains the inductor, first let us find the inductor current. Based on that, we will evaluate I of t. So for finding the inductor current, the initial value of the current through the inductor II is equal to IL of 0 plus is equal to 1 ampere, and the final value of the current through the inductor IF is equal to IL of infinity is equal to 1 divided by 2 ampere. This is because of the reason that inductor acts as short at steady state. So at that time the current can be given by half ampere. Now based on this, the time constant of the circuit can be given as tau is equal to L by R equivalent. Here L is 1 Henry and R equivalent is the resistance as seen from the inductor terminals, which is 2 ohms connected in parallel with 2 ohms. So this is also 1 in magnitude, this is also 1 in value. So time constant is 1 second. From this we see that IL of t can be written as IF plus II minus IF multiplied by e power minus t by tau. So this can be simplified as half multiplied by 1 plus e power minus t u of t ampere. So we got the initial value of the current through the inductor. For finding I of t, we need to find out the value of the current through the 2 ohm resistor as well. So from IL of t, we can find the voltage across the inductor VL of t as L multiplied by DIL by dt, that is equal to 1 multiplied by minus e power minus t u of t. That is VL of t can be written as minus half multiplied by e power minus t u of t. That is VL of t can be written as minus half multiplied by e power minus t u of t volts. So from this we see that the current through the 2 ohm resistor marked can be written as I1 of t is equal to VL of t divided by 2 ohms. That can be simplified as minus 1 by 4 times e power minus t u of t ampere. So from this we see that I of t can be written as IL of t, that is the current through that 1 Henry inductor, plus I1 of t, that is the current through the 2 ohm resistor marked. So upon substituting IL of t and I1 of t that we got, we see that this is equal to 1 by 2 plus 1 by 4 e power minus t u of t amperes. From this we see that the current the current I of t which is a required quantity can be written as half plus 1 by 4 times e power minus t u of t. Hence the correct option which represents the correct expression for I of t is B.